Hey Algebra 1, today we're talking about how to transform a quadratic, so basically when you're given an equation, how do you know how it's going to move the original equation, so the original parabola, which we call the parent function. And if you haven't done the Desmos activity exploring transformations yet, I need you to go back and do that first, because this is kind of like a quick summary over what you should have learned. So I need you to make sure you go back and do the Desmos activity first before you do these notes, please and thank you. All right, the parent function is a parabola y equals x squared that's graphed over there to the right. We compare other quadratic functions to it. It has a vertex at 0, 0, and the width, or the a value, is a equals 1. So it's like the vanilla ice cream of quadratic functions. It can't get any more basic than that, okay? The vertex is at 0, the a value, the width is 1, and so it's as simple as you can make it. Now let's talk about some stuff that you should have learned on the Desmos activity. First up, let's talk about the way it's opening. You should have already learned this. When we look at the a value, we know whether it opens up or down. If the a value is positive or greater than 0, then the parabola opens up and doesn't change anything from the parent function, because the parent function opens up, right? If the a value is negative, then the parabola opens down, and it's called a reflection. Specifically, a reflection over the x-axis. So it flips over the x-axis and flips upside down if the a value is negative. You should have also learned from that activity that by looking at the a value, remember a is in front of x squared. So I should have talked about that probably at the beginning. When you have y equals x squared, that's actually y equals 1x squared. So when I talk about the a value of 1, it's because the a value is 1 and then has a y-intercept and a vertex at 0, 0. Okay, going back. So if you look at the a, which is in front of x squared, if the a value is less than 1, so if it's a fraction, then the parabola is wider, which we call a vertical, this is kind of a weird word, compression, which means it's going to get short and fat. If the a value is equals 1, then it is the same width as the parent function, because the a value here is 1. It doesn't change anything. If the a value is greater than 1, though, like 1.5 or 2 or 3 or 4, then the parabola is narrower, which we call a vertical stretch. Okay, moving on to horizontal shift. You're going to look at the h value from the vertex. You remember when we have vertex form, we have this, y equals a x minus h squared plus k. So we are looking at the h value. Whatever that is will tell us how it moves left or right. So look at the h. Tells you how many units the vertex is shifted from 0, 0. Because remember, hk tells you where the vertex actually is. So we have this, hk is the vertex. So you kind of just have to think about, for me, where's the vertex gonna be? And so will that move it left or right? So it tells us how many units the vertex has shifted from 0, 0. It's called a horizontal Okay, the fancy word for shift is called a translation. So a horizontal translation, which means it's going to move left or right. Vertical shift, you need to look at the k value from the vertex. I'll do this in a different color. The k value from the vertex, which we see over here. Tells you how many units the vertex is shifted from 0 to 0, called a horizontal. Again, that weird word for shift translation. Okay, you have one like this on your assignment today. I want you to do this from widest to narrowest. So widest being first, narrowest being the last. All right. Remember, if it's a fraction, if you look back up here, when you have a fraction, the parabola gets wider. So let's make sure we know what all of our a values are. The a value in front of this one is -1, then we have +3 and -1/3. That's what we want to look at. So make sure we see those. Because nothing else, the a value is what makes it wider or narrower. So our widest graph is going to be the one with the -1/3 because 1/3 makes it fat. So first one, the widest is going to be h of x equals -1/3 x squared. That's your widest. The narrowest one is the one that has a +3 for the a value, because when the a values get larger, the parabola gets skinnier. You should have seen that on your Desmos activity, okay? So it'd be 3x squared. And so the one in the middle, the -1, actually doesn't make it wider or narrower, it doesn't change it at all. So f of x goes in the middle here. So here's your order. This is the widest one, here's the narrowest one. Widest to narrowest. Okay, I'm just going to kind of do some examples now of this. So we know our parent function is this, f of x equals x squared. A value of 1, y-intercept of 0, vertex at 0, 0. So we're going to talk about some like possible transformations. The first one we're going to talk about is a reflection. All right, reflection. If you have something, let's say your new function is, and I'll do my examples. If you want to do these on the back of your notes, you can. Let's say I have g of x equals -x squared. Okay, this is a reflection over the x-axis because of this right here. This negative flips it over the x-axis and makes it reflect. So that's the only thing that's different. So there's your reflection. Okay, now let's talk about wider and narrower. Let's take the function g of x equals 1/2 x squared. So notice that the only thing that's different is this a value in front. Okay, this one is wider because the a value is a fraction or it's less than 1. This is the same thing, 0.5. So this is a vertical compression. Means it's getting shorter, it's getting fatter by a factor of 1/2. Okay? On the other hand, it could get narrower or skinnier if you have a value that's greater than 1. I'll use a different letter. How about h of x equals 5x squared. So this is a vertical stretch because it's going to get narrower. So it's going to get more skinny. By a factor of 5. Okay, that'd be something like anything that's greater than 1, right? So 1.5, 2, 3, 4, 5, and you can keep going. It's just going to get skinnier and skinnier and skinnier the higher the numbers get. Okay, now let's talk about horizontal shifts, which can be left or right. You need to think about what your vertex is actually going to be. So for this one, my vertex, remember you could do plus 0. My vertex is at -1, 0. So it's going to take my vertex and move it left 1. I know that's kind of counterintuitive since this is positive 1, but it's actually, remember for the vertex form, you change the sign. So this is a horizontal, or you can say it moves, let's just make it simple, right? It moves left 1. Okay, this guy has a vertex of positive 5, 0, so it's going to go right 1, which we also call a translation. That's actually a better way to say this. Translation right 1, translation left 1. Neat. Okay, last thing is vertical shifts. Okay, vertical shifts move up and down. We look at the k value, the number at the end. So this guy's going to have a vertex of 0, 3, and the other one has a vertex of 0, -7. Hopefully this one is the easiest out of the bunch. This one goes up 3, g of x, so this is a translation up 3. And the other one is a translation, which just means a shift. Translation down 7 from the parent function. Okay, we're going to do like 2 examples of things all together. Okay, here's 2 functions, and we're just going to like bullet point list out what's happening here. Okay, let's start with the a value. The a value is greater than 1, so it's going to get narrower, which we call a vertical compression. The vertex is 1, 3. So it's going to go right 1, and that plus 3 at the end tells it to go up 3. And that a value here, positive 2, will tell it to open up. Cool, let's do the last one. This has a negative a value if you look in front. So it's going to open down, so it's going to reflect over the x-axis. The a value is a fraction, it's less than 1, so it's going to get wider because of that fraction in front. The vertex is -4, -10. So it goes left 4, and then that -10 tells it to go down 10. Okay, I hope these examples were helpful. Again, if you didn't do the decimal selectivity, we need you to go back and do that. Thanks.